All right, good morning towards afternoon. Good morning, everyone. Thank you for the introduction. Here, we're from Mercari, as introduced before. My name is Andre. I will start the presentation and I will pass the mic to Sho later on. And here's our talk about how we optimize our fine-tuned LLMs when we want to deploy it in production, mostly for, we're going to talk mostly about the inference and testing processes. So the talk will be as follows. We will introduce a bit about our company, just in case some of us here haven't heard of Mercari. We're a company from Japan. We will talk about that a bit more later, and then how we used mostly these two tools called Llama.cpp and Locust, which have been very helpful with our projects. And then we will close the talk later on. It will be a 15-minute talk, so hopefully everyone can enjoy our talk. So a bit about our platform. It's the Mercari app. It's a C2C marketplace app, which I think in a lot of other countries we also have quite similar product. But this is one of the biggest C2C marketplace app in Japan, and where everyone, individuals, shops can sell any types of goods. And in the middle of our business model, it's the C2C marketplace. But other than the C2C marketplace, we have a bunch of other businesses, not only selling goods, but for example, on the on-demand work, people can also open job openings and people can work part-time. It's one of our most recent endeavors. And we have cross-border transactions, which I'd like to highlight a bit on the, like everyone can sell. Most of our sellers are still coming from the Japan market, but people from around the world can browse and buy items from Mercari, and these are some of the most popular categories abroad: China, USA, and Taiwan for now, but we're expanding to more countries going forward. Maybe some interesting categories here. Right, moving on to the slightly technical side of the talk. So after the LLM boom in around 2021, 2022, when OpenAI released ChatGPT for the first time, our company has been trying to look for use cases in which LLMs can improve our platform. And in one of the use cases is what's called the seller hints, in which here, because in Mercari, it's like everyone can sell, and not all sellers are professional sellers. So for a lot of our items, not everything is sold quickly, even though there's quite a lot of demands. There are some reasons for that, and depending on the reason, our platform provides different type of hints to the sellers. And one of the hints is to suggest if there's any missing information in the listing. And to do that, before the age of LLMs, we used a different mechanism, but after LLM came in, it became much more easier to understand unstructured data, which in this case, it's the listing descriptions, which is written in completely natural languages. And every sellers, they have different way of saying the same thing, for example. But because it's such a messy data, it was a big challenge for us. But then LLM came, then it's one of the most useful tools for us to tackle this issue. And in this case, we tried a lot of open weight LLMs, and we just pick up two of the things that we finally used, which is one is the Llama model from Google, and the other one is the Swallow Llama. It was based on the Llama model from Meta, but it's one of the institutes in Japan fine-tuned them with Japanese corpus. And basically, it's as you can see in the screenshot here. So whenever someone lists something and it's not sold after a few days, our platform will try to analyze what's in the description, what should be in the description, but at the moment it's not visible, and the platform will suggest them. Something like this. So here, for example, we extracted different types of information, but we found that in this particular category, materials is one of the attributes that's often written, and it kind of leads to a better sellout rate. And we found that you haven't put this, even though it's a popular attribute, then we suggest this to the sellers. Come Llama.cpp. So in order to achieve this feature, one of the quickest and easiest thing to do at that time was to call OpenAI API. So OpenAI at the time, this was a project from 1.5 years ago. I think at that time, GPT 3.5 was released, and it was one of the cheapest option at the time. But it was still too expensive considering the number of requests coming to our platform, and just estimating the price of using OpenAI at the time was just too much. And we tried several open weights LLM, which is so much smaller, which means it can be hosted in a much cheaper way. And here came Llama.cpp to our aid for efficient inference. So it's an open source project. You can visit the link as written there. And how we use it is that, no worries. No worries, no worries. Entire screen. So yeah, the fine-tuned model itself, we use our own data set to further fine-tune the already provided models. However, when it comes to deploying the models to production, serving millions of active users, it had a we had a quite challenge because LLMs are usually it's very big, and unquantized it's just gonna be too heavy and costly. And here is when Llama.cpp helped us to quantize the models and help us serve the models. Maybe choose. We should go to this one. Oh,
Please make the entire screen.
This
So
choose to choose content.
choose content, choose content, and entire display. Yeah. Okay. Okay.
Sorry for the delay. So yeah, and I just want to highlight like how easy it is to use Llama.cpp. There are many already provided scripts within the repository, and we just need to follow the instructions in the GitHub repo. And one of the thing that we did was because we fine-tuned the model using Hugging Face libraries. We used QLoRa, if anyone has heard. It was a very smooth ride with Hugging Face also, which is also provided for free. But then after we fine-tuned the model, we need to convert them to a slightly lighter and faster format, which came Llama.cpp's help, like just one script, convert HF to GGUF, one Python script provided by Llama.cpp, and we can convert it from the Hugging Face format to GGUF. And not only we convert them, this only converting already brings down the size, but then we can further quantize the model, make it even, like quantize here. Maybe it's similar to compressing the models without losing too much performance. And we have many options. In the end, we decided to use the 4-bit format. And as you can see here, like the size became so much smaller, and inference also became so much faster. And this all means when deploying production, it means cheaper cost, which is a huge thing for, I think, a lot of companies that's serving like a lot of requests online. And what's good about this is it's not only that it's easy to use, but it can quantize the model, make it lighter, while retaining performance, which is what we appreciate a lot. And then not only quantizing the model, Llama.cpp provided an already packaged Docker images for serving these models in production. And let me move forward to the next one. So after we prepared our models for production, we already quantized them. We are ready to serve them to the production traffic. But before we move forward, that we use another tool for load testing to make sure that it's really okay to release this model to our customers. And on this part, show here is an MLOps engineer who helped our team conduct this load testing. I'll give the mic to Show. Thank you. Hello. Yes. Okay. Thank you so much. Yes, I'm Cho. I helped Andre here deploy our model to our Kubernetes cluster, and also before we deployed, we actually wanted to make sure that we can handle the load given the configuration that we have for the pods, basically. So here's where Locust comes in, where we were able to mimic the amount of requests in production and directly use it for the currently deployed pods in development, so that we don't have to adjust on the fly once we release it, and also not overshoot our configuration when we start releasing it. So yes, and more on Locust. It's an open source load testing tool where you can actually mimic an amount of users and requests given your given your custom scripts in Python. So it's a really cool tool. And yeah, basically what we did there is once we deployed the Llama.cpp deployment in our cluster, yeah, we started running the Locust script locally. We basically just created simple HTTP requests for the deployment, and yeah, connected it to our deployment on Kubernetes. And at first, we started using just port forwarding, going through our API gateway. But then at some point, we realized that this isn't too accurate, because it also includes a latency of sending it from our computer into the deployments, right? So another way we tried after that is deploying Locust inside the cluster as well, so that basically we can try what is the maximum request per second that it can handle without latency. Yeah, without the noise of the latency, right? And basically just, yeah, we adjusted the user count and the script even. And the good thing with Locust is you can even add delays inside for each request. So you can mimic how many users and how many requests per second you're sending to the service. And the last thing that's really good with Locust is you have this really nice dashboard. It's a bit small, but feel free to check out later. If you Google Locust load testing, it would show up, where you could actually visualize what is the P50 latency, for example, and how many requests per second. Are you getting a lot of errors as well? And you can even visualize all the errors that happened, and you have the statistics of what kind of errors were happening. Are they 404s? Are they 500s, for example? So yeah, and after that, basically, after we found out that, okay, given this configuration of how many T4 instances that we're using, this is the maximum amount of RPS that we can do. That's when we finalized actual deployment in production, and then we were able to deploy without any issues, basically. So yeah, giving it back to Andre now. Yeah. Right. So yeah, thank you, Sho. So that's how we leverage both Llama.cpp and Locust. And open source tools are a huge thing in our company. And this project that I just presented, it's not only the two of us who are working on it. It was a combined effort from everyone in the company. And not only Llama.cpp and Locust, we are using a lot of other open source tools. So we're as a company, I think we're fully supporting the open source community, because it's been one of the strongest tools in our toolcase within the company to achieve what we want to achieve with our projects, to bring the best user experience for our customers. So yeah, I think that's it on our session. Thank you very much for listening. Do we have